All right, hello. Sorry, just setting a few things up. Sweet. Yeah, awesome, everybody. Hello. So, this is my first stream. Let me know if you can hear me okay. Well, I guess there's nobody here yet. It's actually my first stream ever, so super excited to be here. Thank you for joining. I'm assuming when you join a bit later, right? Let me quickly try to take a second to fix this volume here because it's sounding a bit weird. So be right back. All right, awesome. We are back. It actually just sounds a bit weirder on my on my headphones right here than it does actually sound on the stream. But any case, when this deserted land gets a bit more crowded and you can hear me okay, let me know, and if I need to fix anything, we can get that done. Awesome. So today I want to be fucking around with GraphQL and GoLang, right? And I think it will be an exciting way because my whole purpose with this stream is like learning things live where I go through the trouble of understanding certain things and just kind of like reason about it and actually try to fix it there, which I think will be super exciting for us to do, right? I do see that we have two viewers. I can't see who they are, so hello. um, so, okay, perfect. You guys can see my screen here. So we can get rid of all of that. All right, sweet. So what are we actually going to start taking a look at today, right? We will be mostly checking this library called gqlgen. Um, and this library is just essentially the implementation for GraphQL in GoLang. If you're familiar with GraphQL, there is, I'd say, like the two main concepts is that you have your query, which is um, from the names, like it has a query that you have to specify in order to get data. You can think about it as like the equivalent of a get request when you're doing like regular REST, but it's a bit more than that because in REST you're kind of say, hey, I have this one endpoint and I want to go to that endpoint and get data back. And in GraphQL, you can actually specify, hey, I want like a user, and this user have like some books, and now this books have a date, and it could have like an ISBN or something. And then you can like nest all of these and you send that request and it would come back as one package with all the data that you requested, right? Um, so that's the concept of a query. And in the mutation, it's kind of like whenever you're doing a change and you're asking for things to change, like, hey, update this book title or update the book author or delete the book, right? These are all are qualified as mutations. I actually haven't really fucked around much with JQL, so we'll be doing some interesting things today. Uh, let's start a project, honestly, right? All right, so I'm just gonna create that learning GQL1 and we'll get in it. Sweet. And now we'll just go do a go mod, right? So go mod net github.com/opamb/learning GQL. Malform path, okay. All right, so it would have to be something like, let me just copy that again. I don't need to worry about including the HTTPS. Great. So now I'll go to our GoLang and we can rock and roll. I wish I was a Vim user sometimes, you know, when things just doesn't have to take time to start. But to be honest, this IDE is quite freaking amazing. So I do love it, but you get the drawback when OBS is running and like a few things. It now like becomes that heavy IDE, you know, it's not as nice as Vim. But if you're gonna hate on me, go yourself, you know. So, all right. So, first things first, we're gonna go to their documentation and see how to do this thing. And before the stream, I actually tried to have like a quick look at it, and I saw this thing about like introducing tooling into your project, and that's essentially, let's say you have a specific CLI that you need to use to generate code for you, and that CLI you need to make sure that everyone in your team have the same exact package, the same exact tool version to use, right? And I went into this freaking rabbit hole of trying to understand how Go like is doing that, because if you have ever done like JavaScript or like any of the front end world, you have like npm and you just do like npm install everything and everything just kind of like package for you, so you can say, hey, this is my dependency as a dev, this is my dependency for production, and you don't actually have to worry about anything. But in Go it's slightly different, right? Because you don't really have the true distinction between dev dependencies and prod dependencies, and this is where the rabbit hole started. I will talk more about it as we go, and we're gonna hit it in like the first few pages, right? So let's see. gqlgen is a Go library for building GraphQL servers without any fuss. All right, let's see if that's true. So it's a schema first approach. Great, means that you define your types and you go from there. That's pretty good. You have type safety, so no freaking that like interface and stuff. And it does that with the code generation. Okay, pretty interesting so far. I dig. Still not convinced enough. Compare JQL with other GraphQL implementation. Right, let's compare it just for the sake of it. Okay, so we have Gophers. Let's actually go and check the repository as well. The goal of this project is to provide full support for the October 2021 GraphQL specification with a set of idiomatic, easy-to-use Go packages. While still under development, internal API are almost certainly subject to change. This library is safe for production use. Okay, let's actually see. Let's go back and see what the list does. So JQL supports query, mutations, subscriptions. Where Gophers, they don't support the mutation. That's like the core thing, you know, like query and mutation. Like, I understand if you don't have subscription yet, but the query and the mutation, that's kind of like the bread and butter of GraphQL. So how you're not supporting mutation but it's somehow production ready. Maybe I don't know what the fuck I'm talking about, but that's the whole point of this stream. We're figuring stuff out. All right. We've got type safety, type binding, embedding, interfaces, blah, blah, blah. So general enums, inputs, federation. Okay, cool. So it seems like it has the widest support of like the GraphQL features, I guess. All right, so let's go back and see. All right, so you create a project and sweet, that step is done. And then you say add GitHub to your project tools.go. All right, and here, guys, this is literally the place that I was talking about. I went into like a freaking hour-long rabbit hole, right? And the problem here is you have that CLI that you want to use, and you want to make sure that the same version is being used across the entire team. That's cool and all, but how are we gonna do that in Go, right? Okay, so you want to use a Go based tool. They're giving that example of Stringer, which is a code generation tool that essentially implements this string interface, right? While working on a module. And you want to ensure that everyone is using the same version of the tool while tracking the tool's version in your module's Go file. Okay, great. So now this is the recommended approach, okay? And I'm not sure if I'm crazy or unexperienced or what is it, but I don't love it. It works, but I don't love it, right? So now the recommended approach is like you add the tools.go file and you include the import statements for these tools, right? So you have like something like a stringer. But the stringer is a main package, so when you import it, you can't actually use it because it wouldn't even compile really, because there is no such thing as compiling a main package to use as a library, right? A main package is just supposed to run. So what does that do then? Well, it apparently what it does is by you doing that, it adds the dependency to the Go mod file and locks in the version for you if you specify it. And now you can just make sure that you can use it, but that part of the code is not compiled. And that's why you say the Go build tools, I think they call these directives. Yeah, so by adding the Go build tools directive right here, you ensure that it wouldn't be compiled and built, right? So, okay. Now the import statement allow Go command to precisely record the version of the information in the Go mod file, while the directive, oh, it's called build constraints. Yeah. So the build constraint prevents your normal build from actually importing your tool. All right. That kind of summarizes this. I also saw that you can technically just do like go install and you specify the tool at the version, right? Which will install a specific version for you if you're in Go 17. Actually, let me just pull up OBS, see what you guys are seeing. Okay, so if I do Go version, I'm in Go 119, so we have that version. So we've got a couple of approaches here. It's either that we use the Go file, or we can just say the tool name and we can like tell the team, hey, use it from like that text file or whatever. And I think we'll just go with the tool way, because I think it's interesting to see. And to be honest, it really threw me off when I saw it. So they kind of did like, they tried to simplify your life a bit by adding like the build tool. What did we call it? What did we say it was? Build constraint. Yeah. They added the build constraint for you and the imported package, right? And they added to a file called tools.go. Let's do it our way and see if it actually works or not, right? So here's what we gotta do. We're gonna go create a package called tools. So I'm just gonna create a folder. I'm just gonna call it tools, because the learning GQL, that will be like your, whether it's your server code or whatever, you don't want the base package to be called tools. So you will put it into a subfolder essentially. And we will go to this and we'll create another Go file. And here is our tools.go package tools. And we'll do these couple of import statements, right? So they are importing the gqlgen, which is the tool that will help us generate our schemas for GraphQL. Okay, right? So that's the first one. And here's the second one is introspection, right? And introspection is the concept where you can, sorry. Yeah, so introspection just allows you to like say, hey, what type of this schema, and we will see that. I'm jumping the gun here. All right, so you just did the Go tools, and now clearly it's complaining, right? And let's see what it's actually complaining about. Cannot resolve reference symbol github.com. What do you mean? What do you mean you can resolve that? You know what? We do go mod. Well, actually, go get dot slash. Right. It's not within a module rooted. I think it was go install then. Go tidy, go mod tidy. Right. Great. And now it's like finding these modules. So now if we actually go here, we see that the require this JQL version. But of course, we forgot the build directive, right? And the build directive is essentially, I think you do that and you say plus build, and I'm gonna call it tools. So this way it wouldn't run unless it's build tools. But here's something that you really need to know. Like that, it wouldn't work and it's probably complaining. And it says package comment should be in the form of a package tools. So it thinks that this is the documentation for the package, which is not the case, right? What's actually happening is if you click enter, here you go. Now it understands that it's a build constraint, right? And it fixed it for me, which is the go build tools. So that's great. And let's confirm if this is the equal, right? So sorry guys. Okay, so the add the plus tools, I guess that's the new syntax. Let's Google it. No, actually, I think we were in the right place. Package constraint implements parsing and evaluation, build constraints lines. The packages part both. Yeah, so the original like comment plus build, or the new go directive after go 17. Wonderful. Okay. That's kind of like all what we needed to know. And now, as you can see, it's not even complaining about these packages anymore. So that's great. All right. Now it says initialize gqlgen, config, and generate models. All right. Let's do that. We will. I hate when commands just like hang without any like feedback. Yeah. I was watching the Prime Man recently, like or one of his streams, and he was talking about was reading the GitLab guy that like deleted production. And one of the issues was like if literally he waited a few minutes, we could have avoided all of that. Of course, that's not like everything to it, but I found that the most like sad out of the story. Um, so yeah, make sure guys there's like always a verbose option whatever you're building, right? Don't just leave it up to the user to guess or user patience. All right, so let's see what the hell this generated. Okay, so now we have this graph directory and we have the JQL YAML. We have a server.go. Is this the organization I would do in a real project? Probably not. I wouldn't like have my package main actually here. And the reason for that, like I usually like have a command and would include like server and stuff, and I would code it for testability. And we'll probably get to that actually in this stream because one thing I've noticed, I've watched a lot of tutorials and stuff where they really focus into the core thing that they're solving, which is great because that's literally why you clicked into something to actually go there and see it. But then you don't really learn like the full story. Like you only get a very tunnel vision view of the story, and you have to go and figure out the rest. And that going and figuring out the rest could be much simpler if these tutorials actually kind of like did it like how they would do it at work. And now you kind of like have a general idea of what real patterns are, and you can reason them. You can reason about them the same way. Be right back. All right. Okay. Um, I'm not really sure if you guys can see my screen just fine or not, but let me try to like expand this and see. I honestly can't tell. Yeah, I think that's fine. Maybe I'd zoom in a bit. Okay, great. Wonderful, wonderful. All right, so now what? Now that we ran this, it says start the GraphQL server. All right, let's start the GraphQL server. Updates to go mod needed. All right, let's tidy up. Here we go. We have this is like the server essentially. There's like it's sort like it serves this tool. I forgot what it's called, but essentially it's like you have this tool like Postman or whatever like baked in, so you can just kind of like play around with your schemas and explore them a bit, right? So let's try and actually have an idea of what the server is doing. Then we'll go and read more and actually start implementing our own model, right? Great. So what is going on? So we have a default port at 8080. Let's see what's included. We've got the log package, the HTTP, the OS, and we have the handler from GraphQL, the playground. Yeah, this is the browser thing that I was telling you around. It's just called the playground. Great. And you have the graph, which is I didn't open it yet, but this is the code generated by the GQLgen. Right, you have your default port, you check if the port is set. If not, you just set it to the default port and you create a server. So handler, new default server, great. So you're just creating a new default server and you're adding executable schema, graph config, and these are your resolvers, right? We will talk a bit more about what that really means. and then you have your default. So when you go to like HTTP like 8080 slash, you go to the playground handler, which is the GraphQL playground, and the endpoint is the slash query, right? So it's kind of like, I think, redirects you, looks like it, right? Um, and then the HTTP handler, it goes to the query, which serves the server, right? And then you just say, hey, I'm connected to this local host of this port, and you start listening to this port, and if anything goes wrong, whenever this actually like exits, you'll log that fatal. Definitely not how I would write any of my server code, but this is a good starting point for us. I mean, we're still like exploring a lot of stuff. So great. Okay, so now if we go to the graph, right, we have this the schema resolvers.go, which is create to-dos, mutation, and query. All right, we don't really know what to-dos or create to-do are. I'm pretty sure these are just like temp schemas that they're implemented. This is not our stuff. And indeed, right? So you have your type to do, type user, query, input, and mutation. We will try to dissect all of that in a second. And then you have this model, right? Which is code generated by GitHub, do not edit, right? Which is essentially took the stuff from the schema, right? And created a struct type with the proper JSON annotations for it. I think we call these labels, right? With the proper labels for them. And based on that, that became like your model. And now it implemented that for you using the generated as well. So you can like start interacting with it, right? You see here the mutation resolver, it only has the create to do, the query resolver has to do's. And bunch of like, I think this is like 1,000 line code, something ridiculous like that, but it's all code generated. You don't have to worry about it. That's type safety for you that they needed to add. And thankfully, we do not have to actually write that code every single time you're starting a GraphQL project, right? Okay, so what do we have? Let's close everything. Let's just focus on the schema for a second. Okay, so we have this type called to do, right? You can, I don't want to say it. I don't want to say it. I don't want to say it, but you can think about it as like a class or like just a container that holds stuff for you, you know? Okay, so you've got your to do, which has an ID. That exclamation mark just means that, hey, it's required. So in GraphQL, when you include something, it's not required by default. If you put that like exclamation mark, it will be required. Great. So you have an ID, text, done, user. Okay, so my to-do have a user, and my user have an ID and a name. Great. And now we're defining query, right? So what are we saying here? We're saying, hey, GraphQL, I want to be able to ask for data of that type. So I'm asking for to-dos, and you need to give me a list of to-dos. But why is it like that, right? So we see you have your uh, array or slice. So yeah, you have your array, and you're saying, hey, I must return an array, and that array must not include any nulls. So this array must include at least one to do, or nothing, but it cannot include an empty thing, and you cannot return null. So you can return me an empty array, right? Which is like saying, hey, what are my to dos? Your to dos is just one array of nothing. Okay. And now you have this concept of input, which is new to do. Okay, which is text, string, and user ID. So an input when you're running a mutation, right? You can think about inputs as your parameter list for a function, right? So if you have like a func add, right, you can have a, which is an int, b that's an int, right? So here, these are your parameters right there. In GraphQL, you can say these parameters as an input, and now that input is a typed input, so you can reuse it just by referencing it, right? So you can do a mutation. So okay, so let me just show you an example. Let's say we have this create to do to, right? But instead of having a new to do and typed, you can say, hey, it will be a text of a string, which is required, and a user ID of type a string, which is also required. So that will accomplish the same thing as the regular create to do. Which is better? It's not about which is better. It's about if you have a big number of parameters, you would kind of like encapsulate them into an object. And the cool part is you can just reference it by name, right? So you're saying, hey, I'm going to be using an input of type new to do. So it's crystal clear what this does, right? Okay, so we covered the schema. Guys, you need to join my stream because I would really love to have you asking me questions and answering things and figuring stuff out, right? It would be absolutely awesome. Um, I do miss interactions, okay? Fuck it, man. Like, we don't go to the office anymore. All right. Okay, so now that we covered the schema, what is this resolver stuff, right? This file will not be regenerated automatically. It serves as a dependency injection for your app and any dependency you require here. Okay, we'll understand more what this is trying to say. But there is a concept of resolvers in Go. So, sorry, a concept of resolvers in GraphQL, no matter what language you're using, right? So in GraphQL, when you're asking for, let's just use this schema here for a second because like it's already defined. Let's say I want to ask for a user, right? So I would say, hey, query, give me a list of all the users I have in the system. Okay. Now that I have this list, right, you can specify nested relations. So you can say, hey, give me all the users to-dos, and based on each to-do, give me their accomplished task, for example, right? And now you have this one query. So let's write like a query kind of thing together, right? This is a schema file, so this commenting format is not going to work, but it doesn't matter. So essentially, like you'll have like a query, right? And you have named queries and unnamed queries, and we will learn about that together in a second. And let's say I want to get all the users, and for each users, I want their to-dos. For each to-do, I want its name. Well, actually, let's start with the ID. We need its ID, we need its name, we need its status, right? And we can also specify like things like I'm trying to think of like even deeper nested relations, right? I think that's enough for the example. That would do it. So now here, right, you're saying, hey user, give me all your to-dos, but you're not gonna implement every entry point from everything and connecting everything. Now that will make your model extremely huge. So what ends up happening is like you say, hey, I have this concept of resolvers, right? I need to resolve the users and now resolve its to-dos. And when you do these resolvers, you can think about them as like function calls that somehow would get the data, right? You can get the data through like using your database, and you can introduce abstractions or whatever, but it doesn't matter. Let's just simplify, right? The simplest form is like you will go to the database, get all the users. You'll go to the database, get all their to-dos. You'll link them together, and you will compile that and package it into one thing and just like respond it back, right? That's the job of the resolver. And I'm pretty sure we will be implementing some today as well. Okay, now what? All right, so let's do that get started tutorial. This tutorial will take you through the process of building a GraphQL server with GQLgen that can return a list of to-dos, create new to-dos, mark off to-dos as they're completed. All right, sweet. We've created the project, check. We created the tools.go, check. We ran go tidy, great. By default, you'll use the latest version. If you want to specify a particular version, go get replace version with the particular version desired. Okay, great, no problem. Building the server, we'll run init. This will create our suggested package layout. You can modify this path in GQLgen if you need to. Okay, yeah, I don't think we covered that yet. So it generated this file called gqlgen.yaml, which you can see here where all the schema files located. Globs are supported, so you can do like regex, globbing and stuff like that, right? Which is like any nested folder that ends up with GraphQLs, right? So here we're created the directory called graph with the GraphQLs extension. This is the one that you can see here, right? Okay. Where should the generated server code go? This is your exec, which is we have the graph slash generated good go, and the package is going to be called graph. Federation, I know it conceptually and I understand like actually, you know what? I don't even know how to explain it, which kind of shows that I don't fully understand it either. We can get back to that. Where should any generated module go? Sorry, where should any generated models go, right? So the models would go to the model under GraphQL. Okay, these are defaults. Again, I would probably change some of these defaults, and I might actually do that on the live stream. So let's see. You've got your resolver, which is layout follow schema. Okay, it's under graph. The package is graph, and it will be called resolvers.go. Optional. Turn on to not generate template comments above resolvers. Okay. And there is more. We can explore them later or as we need to. There is this Autobind. What is this? GQLgen will search for any type names in the schema in these Go packages. If they match it, it will use them. Otherwise, it will generate them. Okay. So let's go. Create the project skeleton. That's completed. So again, let's see what their explanation is. GQLgen YAML, the config file, knobs for controlling the generated code. Great. That's also what we understood. The GraphQL, it's a package that only contains the generated runtime. So this is the under generated. So your entire generated source code for GraphQL, the runtime will be added there, right? That's why it's a 1000 line file. Now you've got your model. You have your model gen here. Resolvers, the root graph resolver type, this file won't get regenerated. So we have to maintain this file. And now we have some schema. You can split the schema into as many GraphQL files as you like, right? And if you also noticed here, this is why it's called, like, you have the star, so you can specify any file you want. resolvers that go, the resolver implementations for schema.graphql. Great, so this one right here, this is where our actual resolvers would be implemented, right? So you can see the create to do is, well, it's already implemented for you, but it uses the mutation resolver. You have this query resolver, right? So the concept of query and mutation that we spoke about earlier is right there again. And this is like the general mutation and the general resolver. And we still need to probably implement these. Okay, great. So let's move on and see. Server is the entry point to your app. Customize it however you see fit. Oh, I will. I will customize that. It's a lot of customization, but it's a great starting point, honestly, so can't complain too much. All right, so let's define our schema. It says gqlgen is a schema first library. Before writing code, you describe your API using the GraphQL schema definition language. Okay, this is for smart people shit. All right. Okay, so it's just a schema. It's just a text file that you say, hey, this is how I want things to look like. This is how I can relate them to each other. This is what a schema is. All right, so let's move on. So by default, this goes into the file called schema GraphQL S. Guys, this freaking S like threw me off so many times, but yeah. So you can break it up into many different files as you want. Okay, we got that. The schema that was generated. Okay, we've already seen that. So let's implement a resolver, I guess, right? And again, remember, we're learning about these things like live together, so that's pretty interesting. We're literally just like figuring shit out, and that's the most exciting things that we can do. I missed like going to hackathons with my friends and like having shit ton of Red Bull and like learning about stuff for the first time and having to act like that we got our shit together and actually build something that's like, hey, this provides value, and it actually doesn't. It actually works. It's yeah, fun stuff. All right. So when executed, gqlgen generate command compares the schema file, okay, with your models, which is the under the model, and wherever it can, it will bind directly to the model. That was done already when you init. We will edit the schema later in the tutorial, but for now, let's look into what was generated already. Okay, if we take a look at the schema resolver go, we will see that the gqlgen couldn't match them up. For us, it was twice. Wait. If we take a look into the schema resolver.go, we'll see all the times that the gqlgen couldn't match them up. For us, it was twice. All right, if we look into the schema resolver.go, create to do and to do. I'm trying to find out when they said you can find how many times it couldn't match them up. For us, it was twice. Are they just like referring to the two things that we have, which is like create to do and to do? Okay, let's go to the schema, right? So we have mutation, which is create to do, and we have the query, which is to do's. Create to do and to do's. I'm really not sure what they are referring to as twice. So we generated the command compares the schema GraphQL, which is right here, to the model, right? To the model right here. Okay, so we have to do is matched up, the user is matched up, and then you to do is also matched up. The query and mutation are implemented I think, and the schema resolver did go. Well, not really, not really. Okay, so it tries to match them up. And it will bind directly into the model. Okay, that was done already when you init. We will edit the schema later, but for now, let's look at what was generated. If we take a look into the resolver.go, we will see that all the times the GQL couldn't match them up. For us, it was twice. Guys, I don't know what this twice was, but anyways, we will just accept that it did it twice, and it will probably show up later, right? So we just need to implement these two methods to get our server working. First, we need somewhere to track our state. Let's put in the GraphQL resolver.go. The GraphQL resolver.go file is where we declare our app's dependencies, like our database. Like our database? What? First, we need somewhere to track our state. Let's put it into the resolver.go. Okay. The GraphQL resolver.go file is where we declare our app's dependencies, like our database. It gets initialized once in server.go when we create the graph. I'm not sure I would put my database stuff here, but we will run with the tutorial, then we fix it, right? So yeah, let's do that. I was gonna go into the whole rant about why we should just like follow like the tutorial, just learn the basics, then refactor, rather than getting too hooked into like just trying to refactor something that we don't fully get yet, right? All right, so let's monkey patch this shit. Then we clean. Then we put our suits up, and we look like fine gentlemen. All right. So the type resolver struct, they added the to-dos, and they say it's a list of model of to-do. All right, let's do that. Let's do that. You want me to do that? Fuck it, we'll do that. All right. So type resolver struct, right? What is it? It said it's gonna have to-dos, right? And these to-dos are gonna be a slice of the model dot to do. Okay, now what? Returning to the schema resolver to go. Schema resolver to go. Actually, let me have that schema resolver to go here. And the resolver here. I don't think we need that. All right, guys, let's have a look at this. Let's implement the bodies of the automatically generated resolver functions. For create to do, we'll see the math.rand package to simplify return the to do with a randomly generated ID and store that in the in-memory to-do list. In a real app, you're likely to use a database or some other backend service. Man, it's fucking tiring. All right, let's do this. It's very long sentences. Like I need like an oxygen tank or something, you know. All right. So we have the mutation resolver, which create to do, takes a context, and it takes the input, which is the new to do, right? Okay. And now it would return us a to do and an error, right? Okay. So let's see. So the create to do right here is a resolver for the create to do field. Great, right? And the create to do field again is coming from this mutation, and it accepts an input, right? So it will map, whenever it gets a mutation, it will map this create to do to this create to do. Okay, it's straightforward, but you might be wondering why context, right? And we need a way to kind of like track the request, and we'll just GraphQL will automatically put it to you into the context, so the context will provide you with some more information. Okay, and how do they want to do this? So they want to create like a random int, okay, from ran.reader big new int 100. Okay, so they're trying to generate like an ID, right? I see. Okay, so so they create a rand, and they're ignoring the error. Bad boys, but whatever. So we have our rand.int. Bum, 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 bum. Let's call this like rand.int. Right. Rand.reader, which is an IO reader, and rand. I think they did it as like big.new end. I'm assuming big is like a big number. And they put 100, right? Let's quickly peek at what this big thing is. And yeah, it will probably be like for big numbers. Right, we can explore that in a bit, but yeah, so I don't want to divert too much. And the rand.int would return, yeah, a big integer and an error, right? So we'll have an error. If error is not nil, we'll return nil. And an error. And what is it complaining about? Cannot assign a big int r. Cannot assign a pointer to big int to r. Type mutation resolver in the multiple assignment, right? So do you need to take like a pointer to the big int? Not really, not according to their code. Am I missing something? In multiple assignments. Interesting. Cannot assign big int to r. Type mutation resolver in multiple assignments, but it does return. It returns a uniform random value from 0 to max. It panics if max is less than or equal to 0. I don't know why it's kind of like seeing. Oh, yeah, okay. The error message was clear, right? I was gonna say like it's saying that the R is reassigning that mutation resolver to type big int, right? And I was like, where is this R is coming from, right? It's supposed to be complaining that I haven't used this variable yet. So I'm just gonna say random. The reason why I'm not using grand because I hate to conflict with the name, even though that Go can like figure it out. I just don't like to conflict with the name of the package. So be it, right? Let's close that. Okay, so now we have a random number. Then what are they doing? So we're creating a new to do. Okay, so we have a to do, which is a model dot to do. Why didn't we? Well, I guess the new to do is actually it's a type. It's not a function, right? So if we go to um yeah, input new to do. But I want to actually see it in the, I think the resolver. I think it was, yeah, the models. Yeah, you see here, it's a type new to do. So I would probably name it something else, but that would do it for now. Here, fill all fields, great. So let's say this is, what did he call it? The text input.text. Right. Okay. So because this is created to do and it takes the input, right? And we saw that the input in the schema right here has a text and a user ID, then we can totally use that text because you already have it, right? Because that's what the user needs to create. So that's the input.text. Wonderful. All right, is it done? Now we'll set it to false, and the user will be the input dot user ID. And what is it complaining? Is it different types? The user ID is a string, and the user is actually an entire object, right? So let's see. Yeah, so they just have to do it like that. So model.user, just put it in a new line, man, like, okay. And here's our ID, input.user ID, and we'll just like the name. We're faking the name right now, so it will be the user input user ID. Okay, that would do it. All right, and we haven't used the random number yet, so let's do that. So we're creating an ID is called T, and we're just passing the number. Okay. Interesting choice of the D, but I'll just do it their way for now. And we will refactor this. And we might actually just also look into how we can test it as well. You know, it's quite important that we make sure that we're testing stuff. All right, so T%D for the number, random. Great. Now we have a to do. Now what? Well, we need to return the to do and an error, so we're gonna return our to do, and actually an error. In that case, it's nil, right? Let's just return nil. We should create another stream about like error handling and like passing errors back and stuff. I think it would be fun. Right. So now it's adding the r.to2s to the list and memory, right? So the R, oh, I see, I see. Okay, so now we understand what that resolvers are, right? So when we went to that resolver.go and they talked about it having like managing our states. So it serves as a dependency injection for your app and a dependency, add any dependency you require here. But earlier they talked about states, right? And they said we need somewhere to track our state. Let's put it in the resolver.go. The resolver.go file is where we declare our app's dependencies. So like our database, it gets initialized once the server.go when we create the graph. All right, so it will be initialized, I'm assuming exactly once, right? And this is where you can put your state here. So maybe that would be a good place to like initialize your repositories or whatever. We'll get into that. It's all fun stuff. So yeah. Cool. Now what? Now I need water. All right, we're back. Um, so now we have our resolver, which contains our states, which just have our to-dos. we'll append, which is we're gonna append our our to-dos in our to-do. Magnificent. Okay, so now that we have that state managed, right? Create to-do here. This is maybe where you call your repository or something to implement that use case. I don't want to spoil maybe later how we're gonna refactor this, but that would do it for now. We have an in-memory state that works. That's great. Wonderful. Okay, now what? And okay, so we created all of that. And now the to-dos, we'll just return that, right? Okay, easy peasy. So if we go to the to-dos, it returns a list of to-do, right? An error. So think about like, hey, select all, or just return everything that I have in to-dos for me, right? And as you can see, if we go to the schema and you see the query to-dos, it returns a list of to-do that is not null and is not empty. Okay, it's very important because you have to return at least a list. You cannot return a nullable, even though that this to-do is a slice of a type that like it's a pointer to a to-do, which means that it could include a null here. That would not be the case. That's not the proper way to return, right? So you kind of have to comply to your schema. So I'm just gonna return r to-dos and now just I want to show you something. So let's say we can return nil and nil. Again, according to Go, to the compiler, for all what it knows, this works fine. You're saying, hey, a slice is a nullable thing. And you're saying inside this slice is pointer, which is also could be null. So you could return null and null, right? Sorry, nil and nil. But that is not gonna work and it will you up, right? So make sure not to do that and comply to your schema. We will do it the right way, then we'll go back, we'll do the nil way and see the type of errors that we run in, because one of the biggest things that you can do to yourself to actually level up, right, is to learn the errors. And I'm telling you, and this is coming mostly from like infraspace and all that stuff. Oh fuck, I should have introduced myself in the beginning of this stream. Oh well, we'll do that in a bit, but I come from an infrastructure space, right? And like SRE and DevOps and all that space. And the most valuable thing I'd say out of my experience is understanding all these different types of errors and the clues they give you. So whenever you see an error, you kind of have like all these tingling clues. A lot of them are wrong, some of them are right, some of them narrows it down, and you start training yourself to be a bit more methodological into how you solve it, right? Um, I read this article a while, actually, no, it was in a book a while back, and they were talking about like all the debugging ways. It was actually Brandon Gregg's book, right? And he was talking about like the debugging ways and like um, just trying different things, random things until something makes sense. And he calls that like, I forgot what the actual name he coined, but essentially that's not a place where you want to be, right? You want to be able to like look into something and kind of like narrows it down, narrows it down, narrows it down until you get the root cause. So I'm actually gonna say leave a to do for us here. Explore turning okay. So now we return the to do, we return the null. Wonderful. All right, now what? Now you have a working server to start it. Our server is already started. I'm pretty sure it doesn't have hot reload. Let's actually see. Here's our playground. Okay, yeah, because we didn't provide any operations, so that's fine. Let's grab our playground here. Wait, where are we? Yeah, we're right there. Okay, So now open your browser. Here's some of the queries to try. And start with creating a to-do. All right, so how do we do that? So you say a mutation. Oh, look at that. You have autocomplete and everything. It's fancy. Something, yeah, I wanted to point out, right, is under the hood, whenever you're sending a query or a mutation, it will be put into an HTTP post request, and that will be the payload of it, right? So it is a text format like protocol essentially. Okay. And why is this important? Because if you're ever stuck and you don't have a fancy tool to use and you want to send your GraphQL request using your CLI, or maybe you're building automation where you're not gonna spin up like a pretty nice browser to do like sending the request for GraphQL, you can just simply do like curl and you put like the proper flags that you need to send the post request, right? And you can tell I forgot the flags, but this is the easy stuff that you can always find out. Okay, so we have a mutation and it's gonna be called create to do. This is just the name of the mutation. It doesn't actually matter, right? I could be like create to do tutorial. So the name doesn't actually matter, but just be good. Have good names, you know. Be a decent person, you know. It's okay. All right. So it completes for you. You've got your create to do, and let's see. All right. Here's you're saying it's a function call, but that's not it, right? Because you need to say, okay, I created to do. What do I need to return? Do I return everything? You can say, hey, I return the ID. I return the text. I return if it's done or not. And yeah, that's fine. Whenever you create a to do, if we go back to our code, right, you only get the same to do back. Okay. So what does a create to do takes? And you to do. You guessed it. You guessed it. You're an absolute winner, man. All right. Um so if the create to do takes a new to do, I think the new to do takes a yeah, it's called we call this an input. And that input is of type new to do. So how do we pass that? All right, and it's just an object right here, and it has text, which is I'm just gonna use to do, and the user ID, which is also a string, right? Okay. I'm gonna say stream to do. All right, and we are user ID number 1. Best in town. All right. So now from your create to do, if it returns a to do, this means it also has access to the user. Let me see if, oh, nope, that's not what I wanted to do. The documentation. All right. So one thing that's super beautiful about GraphQL in general is that it's almost like self-documenting. So we're executing a mutation right now. So I can click on mutations. I can see that I have my create to do, which takes an input of type new to do. But what the hell is the type new to do? I can click on it and I can see it's a text and a user ID, right? And if I go back, it returns a to do. So now I'm into the to do type definition. This is all happening in your browser. This is whenever you have introspection on, this is what introspection is. This shit is powerful because you can go explore your queries and explore your mutation and your model in general, and things just works, guys. Like beautiful. All right. So now, why were we here? We're here because I wanted to show you that when you return the to-do, a to-do includes a user, so you can get user information, right? So I can say, hey, which user is this, and give me his ID. Sweet. And if we notice in the code, right, when you created a to-do, you had to include the user information. Okay. All right, so we have all of that. Let's try to create it. Internal system error create to do data nil. Okay. Why is that? Not implemented. So it does not have a hot reload. I told you. Yeah, so something you'll get used to is a lot of the times I will do errors intentional so we can learn together. Sometimes I will do unintentional errors and I would typically just admit that I don't know it and we'll learn it. So, because that's what we do, you know? You gotta learn. No shame in that. I enjoy it. I'm fucking doing it in like a live stream, you know? So, if I can do it in a live stream, we can just enjoy it together. So, all right, look at that. We have created a to-do. So now it says our ID. This is 53. This is randomly generated. The text is a stream to do. Great. And if I create another one, another one, another one, another one, of course, we have an issue right now, right? And I'll let you guess what it is, but we'll move forward. So now we gotta query all our to-dos. So we're gonna create a query and we're gonna say all to-dos, and it will be to-dos. Give me each ID. So for each to-do, give me its ID. Give me if it's done. Give me its text. And give me the user name for it. So now let's run this bad boy. And bam. Okay, we've got a bunch. Stream to do false, user one. Okay, we created all of these. But that's terrible because, well, it could be. It could be. What I'm concerned about is sometimes if you're recreating the same exact thing, in some use cases, you need to make sure there's only one of it, right? So if I have a stream to do that is done false and it's by the same user, most likely I do not want to replicate it into my list. Even though in something like a to-do app, I might have a stream to do, stream to do, stream to do, and just like have it a list, and I do want them. Okay, so that's where things could be a bit fun. All right, let's move on with this tutorial. So don't eagerly fetch the user. This example is great, but in the real world, fetching most objects is expensive. We don't want to load the user on the to-do unless the user actually asked for it. Okay, so let's replace the generated to-do model with something slightly more realistic. So now we're gonna look into a very interesting thing, right? They pointed out is like if I'm making a query and I am not asking for the user information and I run this, okay, it has actually loaded all the user information here, right? So I got all the to-dos with all their user information. You can imagine this is happening from multiple database calls, and then it just discarded them. So are you wasting my time? Huh? Don't waste my time. I'll find you. And I will. I'm just saying. I'm just saying. Also, I love this sound. Okay. Now what? Wow, we are an hour and a half into a stream, guys. This is amazing. This is amazing, and I can't wait for you all to be joining, asking questions, and doing fun stuff. I'm gonna take 5 minutes, and I'll be back. All right, and we are back. Sweet. Okay, so we described the issue, right? That we don't want to eagerly find data that the user didn't ask about because that's just waste of resources, excuse me. All right, so let's see how we're gonna fix this using this library. So it says, let's enable Autobind, allowing GQLgen to use your custom models if it can find them rather than generating them. We do this by uncommenting the Autobind config line in the GQLgen. So it will search for any type names in the schema in these Go packages. If they match, it will use them. Otherwise, it will generate them. All right. So if we go to the GQLgen, the O2 bind right there, and it's literally right down for you, right? So it's just commented out. It has the proper path and everything set up. Great. And add the to-do field resolver config in the GQLgen YAML to generate resolver for user field. Okay, let's see. So these models are already there. And now I'm saying, hey, I need to define a to-do with the fields user resolver true. So we're getting a general sense of what might be happening, but let's reread this again because it hasn't clicked. And if it didn't click, we wouldn't be able to know how to do it by our own and we wouldn't be able to explore further. So we gotta learn properly. Okay. All right. All right. Let's do that. So we gotta enable the autobind allowing GQLgen to use your custom models if it can find them rather than generating them. So if we have a custom model, it will use it rather than generating them. Okay, because yes, that makes sense now. Remember, GQLgen, you start off with the schema, right? You don't start off with your model. So in many other ways, you can like write your models first, and then you kind of like generate the schema for it, right? This is if I understand it correctly, like how you do a lot of things with like gRPC and stuff like that. It's like you define your things first, and then it's kind of like generate stuff out of it. Versus here, you're specifying a schema first, and then it's creating the types and the resolvers for you. And now you're saying, hey, I will use autobind. So whenever I have a model that you can find, if you can't find the models, generate them for me, and if you can find them, just use mine, right? And then we also add the to-do field resolver config to generate resolver for the user field. So here We're not just gonna like resolve everything. We're saying, hey, I have this model, and this model is called a to-do. It has fields, right? One of these fields is called the user field, and it has its own resolver. So don't just go resolving things out of the blue. I will tell you how to resolve it. I don't know how this would look in like a big GraphQL implementation, if it will get a bit tedious. We are in the beginner's water right now, so let's explore that. We'll go to the gqlgen, right? And here you go. You've added your to-do, you've added your fields, user, and you've got your resolvers true. Now we're gonna create a new file called GraphQL model to-do.go. So we will be creating our own first model right now, right? So these are the automatically generated. Now we're gonna create our own. So now it's gonna be to-do dot go. Wonderful. So what does that model look like? Well, we can go look at it, or we can just open our schema and implement it. You know, it's right there. It's already defined, and typically, whether this is auto-generated or not, you will be doing these schemas, right? So you know what should go in there, and we'll say, hey, it's a type. It's called to do. It's a struct. It has an ID, which is gonna be an ID. I'm assuming it's a string. It will have a text, which is a string, done, which is bool, and a user, which is models, model dot user. I think was it under model? Model gen. Well, we are in the same package, so you just say user. And it's already complaining because the type is already defined. So let's see that. Redeclared in this package. So we are redeclaring it. Okay, so we have our type to do. ID text done user ID user. We have forgot the user ID. Interesting. So now where is that user ID? Where did it come from? So if we go to our schema, if we actually go to the models, right, it doesn't even have a user ID, it just have a user. So, and here it's using a pointer to the user, so it's not just a user, it's actually just a pointer. That's important, right? Okay. I'm gonna leave the user ID until we see how it's used, and then we get back and reason about it, because I can't reason about it just being thrown out of the blue. I can anticipate that, like, if you're using a user ID, it's probably just because you need to be able to get the data back based on the user provided. But we're also passing a pointer to the user, and we'll see. We'll see how this goes. Anyway, so now it's time to run the gqlgen generate. Yeah. Okay. So we go. We'll turn off our server. Great. And go run the gqlgen generate. And failed. Packages that load unknown field ID in a struct literal. If we're gonna go to the resolver.go, schema resolver.go, it's complaining about this ID, of course, because That's how it should look like, right? Great. And as you can see, it removed it from the models. So I'm gonna rerun it again. Okay, and now sweet, everything is going well. It just removed it from the models gen into our own to-do model. So that's great. Now what? If you run into the package no-go files while executing generate command above, follow the instructions in this comment for possible solutions. Well, we didn't run into this issue, so that's good. Now, if you look into the schema resolver.go, we can see a new resolver. Let's implement it and fix the create to do. All right, let's see the new resolver in action. Okay, so now we have a new resolver for the user, right? And notice here that the root for it is the to-do resolver, right? The resolver, I mean, is the to-do resolver. And if we go there, right, you can see that the to-do resolver is just a resolver. It's done by GraphQL gen. You don't have to worry about that much. We will probably like in a stream or so like dig deeper into the wiring and why they did this and what interfaces they're satisfying and all of that, but it doesn't really matter for now. Now we're learning how to drive, not trying to learn the mechanics of the car, right? So this is our first step. We drive, then you open the hood and you explore and we get better. Okay, so now we have a user. If we go to our schema, right, we have a type user of ID and a name, but we don't have anything that is specify, like you're not querying for users or you're not changing the users. The users are already there into this model at least. And but now you have a resolver for the to do. So how this works, let's see. Let's see. All right. What do we need to do here? Okay, so the user, it will be the model dot user, and it creates object dot user ID. Let's copy and paste it, and let's try to understand what's actually happening here. And here's the user ID thing that I said. I'm not sure why we should include. Okay, so we have a user, which is a context, which takes the context and has an object. And the object is the model to do. And it has a model user, it returns a model user and an error. So we need to return a user. So we create a user and we say, hey, this is going to be the object. This to do belongs to that user ID, and the name is the same as the user ID, right? In reality, this would be a call to the database or something like that. Okay, so because of that's happening, we need to go back to our to-do model, and we compensated by using the user ID. And this way, what will end up happening is that your each to-do have just one string rather than like a big object, right? I'm assuming your user have much stuff. And the user has its own resolver. And to be able to retrieve it whenever the user asks for it, GraphQL will use that query resolver under the hood to return it. But the query resolver, the resolver, which is the user in this case, would need to be able to identify which actual user this is. And this is where the user ID comes in handy. I will run again the generate just in case. Great. And so we have our to-do model. Our user is done. But now we also need to change something, right? Because here we're returning this user anywho, which is not what we need. We need to customize that a bit. So here's our user. Whenever we're creating with that. but we're also including the user ID. Okay. The user ID, it's already part of the input. Okay. So how did this help us? I'm not actually quite sure yet. Because we still have the user anyway created, right? But remember, this helps us in querying. It doesn't help us in mutation. Because in mutation, you still need to link it to a user one way or another, right? So it's only when you're querying, it's like if they're not asking for it, I don't want to see it. Okay. I hope that part is clear, right? So finishes touches. At the top of our resolver to go between package and import, add the following line. The resolver to go. And we want it to be between the package and the import. So this says every time we run or like try to build, make sure that every time we run generate, use the go run gqlgen generate, right? This magic comment tells go generate what commands to run when we want to regenerate our code. To run our go generate recursively over the entire project, use this. We can just use go generate, so we don't have to just say go run gqlgen generate. It's already defined here, right? And I don't think anything should really change. Wonderful. And now go run. The server is up and running. Great. If I run I'll create to do, all to dos. I think I clicked on it again. Dude, run. Oh, I created one to do. Remember, guys, this is in memory, right? This is not gonna be a big list, so I'm just gonna create a bunch, and now I can run the old to dos, and we can see all of them here. But now we have a slight optimization that we should have found a way to test um the values and stuff like how much performance would that make a difference, right? But as a rule of thumb is bigger objects that you'll need, do not just like have them included by default. Make a resolver for them so they are resolved this way. This way you only return to the user what they're asking for. And of course use like good design patterns and stuff to be able to isolate like all this layer. This is your API layer from your services and from your model and all that shenanigans for cool stuff. Okay, so that has concluded that tutorial. Let's do something, right? Let's first change our server to Gen because I'm assuming that you'll be doing more stuff with it. So we'll do go get Gen, and Gen is like this very good server framework for GoLang, right? So we'll use Gen. I think it's important to show that part because most likely if you're using Gen, you want to use GraphQL, you don't want to like switch to whatever the hell their server was, right? So I can actually close all of that for now. And now let's see how we can use Gen. In your router file, define the handlers for the GraphQL playground endpoints in two different methods and tie them together into the Gen router. Right. I'm just gonna copy and paste these, and I'm not gonna copy and paste the main just yet. So I'm gonna leave the default port. So here we go. Okay, we have a GraphQL handler. which is going to be a gen handler function. I think I'll do another stream into gen because I played around with it for a bit, and it was pretty nice. It was pretty nice. Now you have the new executable schema and a config. The executable schema and config in the generated.go file. Resolver is in the resolver.go file. Wait, the new executable schema and config are in the generated.go. Okay, fair enough. So now we know where these came from, right? The new executable schema and the graph config, the resolver, directive complexity. We don't have to worry about any of that right now. Great. This is all auto-generated. Resolver is in the resolver.go, which is pointing to resolvers, right? Resolver root. So anything that implements that, which our graph resolver does implement that. Okay, which has mutation, query, and to do. And if you go to schema resolver.go, it has mutation, query, and to do. Ta-da! Okay, now back to server. So this is like a handle func essentially, right? And it would return a function that takes context of type gen context, and the handler will be the serve HTTP, and you pass the writer and you pass the request. So that's for the resolvers. And now you have got your GraphQL gen for the playground. So whenever you go to the playground, so which is like the slash query, you do the same thing. You return a function call which is going to be handled by gen, and you say the handler serve HTTP, and you pass the writer and the request, right? So the playground handler, right? The playground is coming from that library right here by gqlgen, and the handler, right, is also coming from the gqlgen. Okay, you can actually just go to it and explore it if you wish, right? We should do like one of those streams as well. Anyways, that's many ideas. Great, that's great. All right, so now what? Well, now we need to actually implement the main, which is much more concise and much smaller. We'll leave the port stuff. I'm gonna just do that. Goodbye. This line of code literally just like went there, right? We just change the name of the variable. Now we're using gen. Great. Slash. Now we're saying rather than the playground handler right here and endpoints, we are just saying, hey, use the playground gen handler function, which is great. And the handle slash query, and we pass the serve. That's also handled. Now we got a log, the same message, and this guy here, the run unhandled error. Well, actually, I think the r.run would do exactly that. Right. It does the listen and serve, and it returns, and it prints the message. So I don't need to set that. And does it handle the port? If we go to the resolve address, it does handle the port for you as well. So great. So we do not need to do any of that type checking. Not honestly, not even checking the OSM for the port, right? It's happening by default by gen. Goodbye. Great. Okay, so these are handler functions. Now let's run our server. So we're running in debug mode, switch to release mode in production by just setting more like environment variable flags. Great. If you post a slash query, you'll get the GraphQL handler. And if you do the get request, you'll go to the playground. You trusted all proxies. This is not safe. We recommend you set a value. Please check. Gen, okay. Don't trust all proxies for details. And it prints off like environment variable port is undefined, so it's using 8080, and now we're just like listening on localhost. Right, let's go there, and then we will check one last thing. So if I go here, and I go, oh, shoot, all right, localhost 8080, it redirects me to the playground. Okay, so the question is, how does it redirect me to the playground? Because we're saying this, so we're saying, hey, whenever we do get a request, use the playground handler. The playground handler is already specified by the library, and it does all of that for you. Page executes and it returns all that shenanigans for you, which I'm pretty sure that's a template that it's filling. So it's adding content type, text, HTML, page. Where's this page coming from? Yeah, it's the template, right? Great. So okay. So it fills these things to the templates, then so page execute. There is no error. If error is not null, it panics. Otherwise, it already have returned that function for you. And you've specified the title and the endpoint, which is GraphQL slash query, and boom, this just becomes your regular HTTP like handler function. Yeah, it is. I mean, it also says the return type. I don't know why I made this look like rocket science, but anyways, it goes and here like Jen would say, so the gem function would execute. It's like a callback kind of thing, right? And we're saying, hey, serve HTTP, whatever data you get, right? And if we go to the slash query, notice it's a post, right? This is where the GraphQL handler happens. And here, new default server, executable schema. Let's see what this looks like. You've got the resolver directives. If you go to the config resolver, resolver root, we've got this, which is, again, we saw that our resolver implements. What else that we need to know here? New default server. It does some stuff behind the scenes, right? So to add like the transport information, set query cache, it uses introspection, persistence query. So there's more caching related stuff we can learn more about these things. Let's actually see. So the executable schema, which is schema complexity and exec, but does handle like shit ton of like stuff relating how a query would like execute and stuff, right? But all of that is abstracted away from you with these like few lines, which is pretty damn awesome, right? Okay, accessing gen context. The resolver level a gqlgen gives you access to the context object. One way to access the gen context is to add it to the context and retrieve it again. Create a gen middleware and add its context to the context. What does that mean? Gen context to context middleware, which is a function that takes the gen context So what I'm assuming is happening here is that if you need to, so the C here is the gen context, right? And you're saying, hey, I want to create a context with a value. This value is the request context. I'm gonna name it gen context key, and I'm gonna add all the context to it, if I understand that properly, right? And then you have the request with context right there. So see the request equals see request with context. So you're setting, oh, okay. So you took the main gen context, you've added all the context header to it, and then you add it to the request. And then you say c.next, which is like execute next, right? Like this is how you format middleware using gen. The router definition. So, okay, here's you specify I'm gonna be using this middleware. Define a function to recover the gen context from the context struct. Okay, gonna retrieve the gen context, and now we're saying if it's of a type gen context, then we return it. Lastly, in the resolver, retrieve the gen context with the previously defined function. Okay, I see. So I believe let's do this. Let's see it, right? I'm gonna do this in a bit of a wacky way. So if we go to the schema resolver and we create, actually no, let's just do it in the to-dos. And I'm just literally gonna print line the context. Great. We'll go run. I will clear my terminal. I'll go here. I will say give me all to-dos. Okay. And here's the entire context. So type GraphQL.key value with value. Let me see if there is a way I can print out the context dot. Yeah, I wouldn't be able like to get all its values, so we'll just have to introspect it like that. Okay, now let's do something. We'll go to the server and we'll actually create that middleware. We'll say func middleware, and I know it will return func. Let's see, which is gen.context. Great. And I think it's just called another func. Let's see that next. Okay, and now let's do the magic that they were doing. Well, it's not really magic, but let's just do that. So we're creating a context, and from the context package with value c.request. So this is our gen context from the request. Okay, so if there is a context that's already set, it would return it. Otherwise, it would create a new context for us. And we'll add that to the gen context key, and we'll pass the entire context, right? And now the request, so the gen context has the request, and it has a bunch of other stuff, right? So that's how you interact with gen in general. So you can request, you can say, for example, like headers, right? There's many more the params that you get. So and all of these functionalities available to you, that's essentially like your entire HTTP handling that you want to do is happening through the context in Gen, right? It's the decision they chose to take. That's fine. And now you just say, hey, my context request is going to be the request with the context, and I'm passing it in a context, right? So I want to do a request with that new context that I created. That's essentially it, right? And if the context is equal nil, we panic because you shouldn't pass an empty, like a nil context. And it creates a new request. It sets them up, sets the context to the new context, and it returns the new request for you. Okay, and now we say c.next. Now we also need to do the retrieval, right? So the func get gen context, which will return a context. The pointer, I believe so. Let's see how they did it, because I think you had to pass in something. So gen context middleware, that's done. Gen context from context. Yeah, so you pass a context and it returns a gen context or an error. Interesting. Okay, so here I'm passing a context type, and I want to return the gen context from it. Okay, so we need to first check the gen context is equal to ctx dot get value, the value, and it will be the gen context key. And if that's the case, then great. If not, gen context is equal to nil. Bam. Return nil. Couldn't retrieve gen context. Wonderful. Now we say, is it the gen context? Okay, so here's all what I had to do, right? I say, here's my gen context. Please get it from the value, from the context value. If it's nil, meaning that it doesn't exist, then we couldn't retrieve the gen context, which most likely just wasn't added or something removed it. Then we say, we do like a bit of reflection stuff to check the type. We're saying, is the gen context that was returned to us, is it of type gen context? If it isn't, then we return an error. If it is, then we return the GC, which is referring to the gen context. And I'm tired of saying that word, gen. Yeah. Okay. And nil for the error. Great. And now we're missing one thing, is that we're not using the middleware anywhere. So we need to say here r dot use middleware gen context middleware. Great. Guys, the API for gen is pretty darn nice, to be honest. I really like it a lot. Yeah. Maybe Not a fan of the context, but it's needed, it's important, it does the job, it's beautiful. So yeah, can't complain too much, can't criticize too much. Where's my last open source library that was used by a mass number of people? So until then, guys, you can't complain. We can bitch a little, but it's okay. So lastly, in the resolver, retrieve the gin context with the previously defined function. So I'm actually going to do that. So I'm going to go to my to-do, schema resolver. All right. This is the context that I got. This is the gin context. This is from I had that in my main, didn't I? Right. See, that's one of those things that I would like. I wouldn't put my main here, because I want to be able to use these things. And how can you really use these things here, right? So I would have to use the function get gin context from here, and I have to go to the resolver. I'll just put it here temporarily, but the thing is, if I had moved my mains initially to a command and just kind of like leave everything else as a library, then I can kind of like connect my stuff. Is it best to connect all your things? Not necessarily, but it could help. All right, let's just quickly see what difference is. Line JC. I don't think we need this anymore. Bye. Okay. We'll go to the to-do. To-dos. So we couldn't retrieve the gin context. Which is coming from here. Because the context was not added. So if we go to the server and we look at this, let's see if that makes any difference. And I go here, bam, bam. It does make a difference, right? Because it's executed first. So you're saying, hey, I need my middleware before, after. That's important. And as you can see, this right here is like a very different shape than this right here, right? And if we don't retrieve it, we can actually see a comparison here by saying schema resolver and my to do. I'll just print the context. They might be the same now. Right, so this is with type GraphQL keys and stuff, and this is the just purely everything else has to do with gin. So that's cool. We can like do HTTP authentications and tokens and anything that you're used to your gin workflow can now apply here. Now there's one last thing before we wrap it up. That what happens if you have a brand new schema and you want to use it. So now this all seems good and nice because everything was regenerated from scratch. So what if I leave the, like, I go to a schema and I say, I'm done with all this shit. I want a type of book, which have an ISBN, which is type a string, and it has an author, which is a type author. We have a type author, which has a name. And has an ID. Okay. And now I do and go. Right. Undeclared name user makes perfect sense because we have this to do here. So I'm just gonna remove my do file. And if I go to the gqlgen and I remove this stuff, we don't need it anymore. I'm gonna do go generate. I actually wonder what happened. So this is where, like, I'm fucking with things, right? This is where things starts getting a bit interesting, actually. Right, so we can comment all of that. We don't need any of that for now. Let's see. So now we have these things. I don't have a model anymore. And I'm actually just gonna remove the resolver as well. So I only have a schema. Would this work? Make sure you're using an import path to the package that exists. So import path, let's say the word model. Let's make sure that we're reading the error exactly right. And we're just going to disable Autobind for now. And let's read this. Make sure you're using an import path to the package, right? So just complaining about this. But I wish it kind of like said something, right? But now we have our models generated. ISBN, wonderful. We ignore the generated file. We don't touch that massive file and do not edit. So, okay, ignore. And we have our resolver, which is empty now. The schema, we have defined that. And the model generated is this. Now we can do our magic. All right, everyone. Thank you so much for joining. Or thank you for watching, really, if you ever watch this later. I hope you like it. I hope it was useful. have some grace. It's my first stream, and we're gonna have excellent stuff that we will be doing together to level up our coding skills and our knowledge about stuff that are a bit beyond tutorials. So if that was helpful, drop me a comment. Let me know what else you would want me to talk about. Next time we'll probably continue with this, where I'm gonna actually build like a website, and that website will have like it's a blog slash content management kind of things, and we'll implement it with GraphQL now that we have this base knowledge skills of resolvers. And we can continue with it. And we'll also next time we'll go through some of like the reference. So we'll read a bit of the documentation. We'll try to understand some a bit, and then we'll go and we'll implement a few things for the content management. Thank you so much for joining. It was pleasure for me to be here, and I hope to see you soon. Thank you and peace out.